Hello everyone, my name is Yugantan and I'm here to discuss about my DBMS assignment. So let's begin. I'm currently studying in the 4th SEM CSE AI Sri Venkateswara College of Engineering. The course code is BCS 403. So let's begin. The topic is about normal forms in DBMS. Introduction to normal forms. Normal forms are guidelines to organize database schema. They help in reduce redundancy and improve data integrity. Understanding normal forms is essential for effective database design. What is normal form? Normal form is a property of relational database design. It specifies the level of redundancy and dependency in the data model. Achieving higher normal forms typically means fewer anomalies. Importance of normalization. Normalization minimizes the data duplication and database management. It enhances the data integrity and consistency across the database. Proper normalization can lead to efficient data retrieval and updates. First normal form. A table in one NF is all its attributes are atomic. This means no repeating groups or arrays are allowed. Achieving 1NF sets the foundation for further normalization. Characteristics of 1NF. Each column should have contain unique values for each row. The order of row and columns does not matter in 1NF. 1NF helps in eliminate the duplicate records in the table. Example of 1NF. Consider a table with customer order that includes multiple items of one cell. To convert into 1NF, you must separate those items which include individual rows. This transformation ensures that each order is represented distinctly. Second normal form. In a table, in a second normal form, if it is in 1NF and has no partial dependency, this means all non-key attributes must be fully functionally dependent on the primary key. 2NF aims to eliminate the redundancy caused by the partial key dependency. Characteristics of 2NF. A composite primary key can be lead to partial dependency in 1NF tables. Achieving 2NF requires dividing the table into smaller and related tables. This process improves the data integrity and redundancy. Example of 2NF. Example of an 1NF table might include student's grade with student's ID and course name. To convert into 2NF, we separate the student's information and course information into distinct tables. This eliminates partial dependency on the composite key. Third normal form. A table in third normal form is an 2NF and has no transitive dependency. This means no key attribute should be dependent on the other non-key attribute. Achieving 3NF reduces the redundancy and improves data integrity. Characteristics of 3NF. No non-primary attribute should depend on another non-prime attribute. Each attribute must directly depend on the primary key. 3NF helps in eliminating anomalies that can rise from transitive dependency. Example of 3NF. Consider a table with students' major include alongside their ID. If the major department leads also listed, it creates a transitive dependency. To achieve 3NF, we separate the departments into their own tables. Boy's Code Normal Form BCNF. BCNF is a restricted version of 3NF. A table in BCNF is very determinant in candidate key. BCNF resolves anomalies not covered by 3NF. Characteristics of BCNF. BCNF address situations where multiple candidate key exist. It ensures that no redundancy exists even in the complex relationship. Achieving BCNF often requires decomposing table further. Example of BCNF. In a table with employee and project management, if an employee can work on a multiple project, conflicts may rise. To convert BCNF, we would create a separate assignment table. This ensures all dependency on the candidate key. A table in a 4NF is in a BNF. No multi-valued dependency. Multi-valued dependency occurs when one attribute determines multiple values of another. 4NF address issues that can be lead to redundancy in complex relation. Characteristics of 4NF. A relation is said to be in 4NF if only non-trivial multi-valued dependency exists. Achieving 4NF often requires decomposing the relation with multiple independent multi-valued attributes. This process enhances the clarity of relationship between entities. Example of 4NF. Consider table listing students and their hobbies and sports. Both hobbies and sports have multi-value for each student. To achieve 4NF, we should separate these attributes into distinct tables. Fifth normal form, that is 5NF. A table in 5NF is it if in 4NF and all joint dependency are implied by candidate keys. 5NF focuses on eliminating redundancy causing by joining multiple tables. The normal form is often less common but it is essential for complex database. Conclusion. Understanding normal forms is crucial for effective database design. Each normal form progressively reduces redundancy and improve data integrity. Implementing the appropriate normal forms can significantly enhance database efficiency. This presentation provides an overview of normal forms in DBMS, including definition, characteristics, example, and significance of each normal forms. Thank you. This was all about this video. Thank you for watching.